More and more, road construction is coming to mean reconstruction, and that means working near traffic. Drivers, workers, pedestrians all have to share the road, and no one wants to give up any of it. To help ensure the safety of road users and road workers, we set up a system of temporary traffic control using a variety of standard traffic control devices. Those devices represent a thin orange line of protection. It keeps traffic away from the hazards of the work area, and it separates workers from oncoming vehicles. When it all goes smoothly, the work gets done and traffic gets through with relatively little disruption. But the thin orange line is fragile, and when it's broken, the results can be tragic. In order to keep that line of protection intact, and to ensure efficient traffic movement, work zone traffic control must be planned, set up, maintained, and most of all, inspected, just like any other item on the project. This program will focus on the thin orange line and the role you, the inspector, can play in keeping traffic moving safely through and around road construction or maintenance sites. The program is divided into two parts. Here in Part 1, we'll go over some of the sources of information you should be familiar with to help you make better traffic control decisions. After that, we'll discuss the objectives of work zone traffic control and go over 5 basic principles that should be followed in order to meet those objectives. And finally, we'll look at a basic work zone design and describe certain elements that are found in most work zone traffic operations. In Part 2 of the program, we'll concentrate on work zone operations. We'll describe the inspections you can make to help ensure the safe maintenance of traffic and the protection of the work crew. Okay, let's get started with a look at some of the references you should be familiar with for inspecting work zone traffic control. The Manual on Uniform Traffic Control Devices is a good place to start. Published by the Federal Highway Administration, the manual contains the standards of design and use for all traffic control devices. Part 6 of the manual focuses specifically on standards for work zone traffic control. It spells out the design requirements for the devices used in work zones and shows how these devices may be used in a series of drawings called typical applications. Many states and local jurisdictions have developed their own traffic control manuals. All are based on the MUTCD, but some have more stringent requirements. For example, the MUTCD describes the use of aero panels on certain operations as optional, while a local manual might require their use. The MUTCD sets the minimum standards. Often it's necessary to do more. Another source of information for work zone traffic control is your agency's standard specifications. Usually listed under maintenance of traffic, the specs describe in general terms the work to be done, the materials and equipment to be used, and how it's all to be measured and paid for. In addition to the specs, you might also need information from your agency's standard plans or standard drawings. These may contain specific design requirements for traffic control devices, as well as show examples of some common work zone operations. But the reference you'll use most often is the Project Traffic Control Plan. Anytime road work affects normal traffic operations, a traffic control plan is necessary to minimize the risk of accidents and delay that often accompany highway work. On simple operations, a traffic control plan might consist of one of the typical application drawings taken from the manual or the standard plans. Remember, though, a typical application represents the minimum traffic control requirements. They often must be modified to meet the existing conditions. More complex projects require specialized plans that have been drawn up specifically for every phase of the job that will affect traffic movement. A good traffic control plan will spell out which signs and devices the contractor must use, where they should be placed, and other traffic control details. The contractor usually has the option of modifying the traffic control plan, but all changes must be approved by the appropriate engineer, and all copies of the traffic control plan have to be updated to reflect the changes. As the inspector, you too can and should make suggestions for improving the traffic control plan. But don't make any changes on your own. Always get approval first. And again, keep the plan up to date. Two other references worth keeping around are the ATSSA Guide for Work Area Traffic Control and ATSSA's Flagging Handbook. They contain a lot of the same information found in the other references we've mentioned, but they're a little easier to carry around. Okay, that takes care of our sources of information. Now let's go over the basic objectives and principles of work zone traffic control. When you get right down to it, work zone traffic control has only two objectives: to reduce the accidents and to minimize the delay and inconvenience that typically accompany highway work. Ouch! The MUTCD lists 5 fundamental principles that will help us achieve those objectives. Let's go over them briefly. The first principle is that traffic safety should receive the same high priority attention in work zones as it receives on any other section of roadway. That means traffic control has to be an integral part of the project plan and design. It can't be treated as an afterthought or a secondary concern. The second principle is that work zones should inhibit traffic movement as little as possible. To some drivers, a work zone can seem like an obstacle course. They may be confused by the changes in road alignment and distracted by the workers and equipment. The closer we can keep the work zone to normal driving conditions, the better for everyone. The third basic principle of work zone traffic control is that it should provide drivers with positive guidance. Positive guidance means telling drivers what to expect up ahead and then showing them the way. Good traffic control eliminates choices. There should be no question about the path to follow. The fourth principle is that work zones need regular inspection to ensure acceptable levels of operation. This is the principle that most concerns the inspector. Part of it is bookkeeping, seeing that the contractor uses the right number and type of devices, and that he gets paid for them. More important, it means you have a responsibility for the performance of the traffic control, seeing that the contractor sets it up and maintains it according to plan, and noting what improvements could be made. In response to this principle, many agencies require the contractor to appoint a traffic control supervisor to oversee project traffic operations. This person must be well trained and able to make traffic control decisions without consulting with his or her supervisor. Some agencies further require the traffic supervisor to be certified by the American Traffic Safety Services Association or to hold an equivalent certification. If that's the case, you should make sure the traffic supervisor's credentials are up to date. The fifth and final principle is that work zone traffic control should include provisions to maintain roadside safety. This means that we should try to provide recovery room for drivers who make a mistake. One way we can do this is by keeping construction equipment and materials away from open traffic lanes when possible. Maintaining roadside safety also means ensuring that traffic control devices themselves present little hazard to oncoming vehicles. The use of crash cushions at the upstream end of a concrete barrier is an example of this principle in action. By including these 5 fundamental principles in the development and the implementation of our traffic control plan, we will be on our way toward meeting our twin objectives of reducing accidents and minimizing inconvenience in highway work zones. Okay, now let's take a look at the basic design of a typical traffic control zone. The MUTCD divides traffic control zones into 5 distinct areas, each with its own function and set of risks. First, there's the advanced warning area. This is where we warn drivers, primarily through the use of signs, that there's road work ahead and that they should prepare for unusual conditions. The next area is called the transition area. In this segment, drivers move out of their normal travel path and into one that's required by the work zone. Because the transition area usually requires a merging movement that drivers may be unaccustomed to, it's the site of many work zone accidents. When the transition area involves closing one or more lanes, the contractor sets up a line of channelizing devices in a taper to force traffic over from the closed lane. If space allows, a buffer area comes after the transition area. This is simply a recovery space for drivers who fail to make the transition from the closed lane. In keeping with the principles we discussed earlier, it's important to keep this area clear of construction equipment and materials. Following the buffer area is the actual work site. Here's where the crew and equipment are located. Very often, all that separates them from traffic is our thin orange line of traffic control devices. The last section is the termination area. This is where traffic resumes its normal patterns. The termination area is typically indicated by an end construction or end roadwork sign. You'll see a lot of variations to this basic design, but the majority of work zones will include most of these elements. Again, the important thing is that the work zone is set up according to the traffic control plan. No changes, no substitutes without prior approval. Okay, that takes care of our introduction to work zone traffic control. In part 2 of the program, we'll go into more detail about the kind of inspections you'll be responsible for out on a project. This is part 2 of the Thin Orange Line, a program for construction inspectors who are responsible for traffic control in work zones. In this part, we'll look at 3 elements of work zone traffic control: the selection, placement, and maintenance of the traffic control devices. Let's start with the easiest: selection. Basically, you just want to make sure the contractor uses only approved devices that have been specified in the plans and that conform to the requirements of the MUTCD or your agency's own traffic control manual. For example, non-reflectorized traffic cones like these may work fine for many daytime operations, but you can't allow them for nighttime use. Here's another example. Flashing lights on barricades are good devices for drawing attention to isolated hazards. But for delineation, you'd use steady burning lights that outline the safe travel path. The point is, the contractor must use the signs and devices specified, not what he happens to have on the truck. The devices must be made of approved materials, and they must meet the minimum standards of size, design, and color described in the MUTCD or called for in the plans. And that's all there is to selection. Now let's talk about the placement of traffic control devices. Again, the plan should specify the locations and spacing for all devices. The MUTCD supplies some guidelines on placement as well. For signs, there are 2 placement concerns. First, signs must be easily seen. In fact, they should stand out from their surroundings. Second, signs must be placed so that drivers have sufficient time to recognize them, read them, and react to their message. Check the contractor's sign installations for location and workmanship. Signs that are obscured by vegetation or the road alignment should be relocated with the permission of the engineer. The manual states that the bottom post-mounted signs should be at least 5 feet above the pavement in rural districts. In urban locations, the bottom of the sign should be at least 7 feet high, so it'll be more easily seen above traffic. Signs that are supported on portable stands must be kept at least 1 foot off the ground. Remember, all of these heights are minimums. Conditions at the site may require increasing the mounting height. As for sign spacing, the manual recommends placing advanced warning signs at 500 to 1,000 foot intervals on highways with high traffic speeds. The last warning sign should come about 500 feet before the transition area. On lower speed roadways, such as city streets, the contractor may use closer sign spacing. Another case where correct sign placement is important is along detour routes. Periodically drive the detours to check the placement and quality of the signing. Ask yourself, if I were a visitor, could I find my way? Bring any problems you find to the attention of the contractor or his traffic control supervisor. Sometimes lights and flags may be required to draw attention to work zone signs. Make sure those devices are installed according to plan and kept up throughout the project. 2 more points about sign placement. First, see that the contractor covers or removes any sign that doesn't reflect the current roadway conditions. Inaccurate signing decreases respect and confidence in our traffic control efforts. And second, the contractor may not install any temporary regulatory signs without the approval of the agency that has jurisdiction over the project. Some common regulatory signs used in work zones are speed limit and road closed signs, as well as stop and yield signs. All must be part of the approved traffic control plan. The placement of channelizing devices in work zones also requires your attention. 2 things in particular that should be double-checked are taper lengths and device spacing. These formulas, taken from Part 6 of the manual, are often used to figure taper lengths on multi-lane roadways. As you see, taper lengths are related to the width of the lane closure or offset and to the traffic speed. Tapers on 2-lane roads must be much shorter, no more than 100 feet, and require the use of flaggers to regulate traffic. The spacing of devices in a taper is also related to traffic speed. As a rule, the maximum space between devices in a taper is a distance in feet approximately equal to the speed limit or prevailing speed in miles per hour. So for traffic moving at 50 miles per hour, the maximum space between devices should be no more than 50 feet, and very often it should be less. In the tangent section of a lane closure, the space between devices can be increased. Typical spacing is twice that used in the taper, but as a rule, not more than 100 feet, even on high-speed roadways. To improve delineation around curves, or in areas where existing pavement markings are left intact, you may want the contractor to use a tighter spacing of devices. That will provide more of that positive guidance we discussed in Part 1. Check the lengths of tapers and the spacing of devices. Both should be at least what's called for in the plans. Tapers in areas with sight obstructions, such as hills and curves, may need to be extended so drivers don't come up on them suddenly. Also, look at the alignment of the devices. In a good taper, the devices will be offset from one another so that to approaching drivers, they look almost like a continuous wall. Continually check the transition area for skid marks, long queues, and evidence of collisions. They indicate drivers are having a hard time merging and may mean the taper should be longer. And if vehicles consistently move in between channelizing devices, a tighter spacing of devices is called for. Of course, when it's absolutely critical to keep vehicles from penetrating the workspace, a temporary concrete barrier might be a better choice of device. You also should check the placement of temporary pavement markings. As with all devices, pavement markings must be the type specified and placed in the proper locations. When work zone markings will conflict with existing markings, the contractor may be required to remove the old lines by sandblasting or another approved method. Blacking out the old markings by painting them over is generally not allowed. Refer to the contract to find out how much removal is required and how it's to be measured and paid for. Even after removal, old markings are often visible enough to confuse drivers, especially at night or in wet weather. The contractor can compensate by using wider temporary lines, raised pavement markers, or a tighter spacing of channelizing devices to give drivers better guidance. Aero panels in work zones also require placement consideration. They're most effective when they're placed on the shoulder at the beginning of the taper. On roadways with little or no shoulder, they need to be placed further back, but the closer you can get them to the start of the taper, the better. Contractors should not use aero panels in situations where a lane isn't actually closed, or for lane closures on two-lane roads, or for shoulder closures. Aero panels in those locations can lead to unnecessary and sometimes dangerous lane changes. Changeable message signs, when required, should be stationed at the planned locations. Drivers should have enough time to read the entire message series at least twice before they pass the device. And when warning lights or other devices are used to delineate concrete barriers, you have to check the spacing of those devices. The spacing should be according to plan. Now, a few more points about the placement of traffic control devices. Make sure the contractor maintains safe access to homes and businesses in the project area. Look out for signs or other devices that obstruct the vision of drivers entering the work area from parking lots and driveways. Also make sure that the contractor maintains pedestrian access where necessary. If pedestrians aren't given enough warning and guidance, we may be forcing them to make unsafe decisions. Okay, that does it for placement. Now let's talk about the maintenance of work zone traffic control. The maintenance requirements for work zone traffic control should be spelled out at the pre-construction conference and in the project plans or special provisions. Without written and agreed upon requirements, enforcing the standards is more difficult. Let's go over a few typical requirements. Maintenance of work zone traffic control primarily concerns two things: the position and the condition of the traffic control devices. We've already talked about position as far as the installation of devices goes, but over the course of a project, signs and channelizing devices are often moved out of their original position and alignment. The contractor must maintain the planned position and spacing to provide drivers with the positive guidance they need. Maintaining proper alignment is especially important for flat-sided devices, such as signs, barricades, and vertical panels. If they aren't kept perpendicular to oncoming traffic, they lose some of the retro-reflective quality that makes them so visible at night. The same thing goes for the position of warning lights. To be most effective, the lenses have to face traffic head-on. Otherwise, drivers lose the guidance they provide. Now for the other side of maintenance, the condition of traffic control devices. Of course, all devices should be in good condition, not necessarily perfect or like new, but reasonably clean and bright and relatively undamaged. Some agencies have written and illustrated standards that describe when devices should be replaced. But in most cases, it's still a judgment call on the part of the inspector. Here are some things to consider. The purpose of the device. Any device that's installed to warn drivers of upcoming hazards must be maintained at a high standard. When drivers don't receive adequate warning, accidents and lawsuits are frequent results. Also consider the overall system of traffic control and the role a particular device plays in the system. One dirty channelizer out of 100 on a daytime job isn't a big deal, but a series of poorly maintained devices that are supposed to provide nighttime delineation can't be ignored. All signs and channelizing devices that will be left on the road at night must use an approved grade of reflective sheeting to provide sufficient nighttime visibility. The condition of the sheeting largely determines the effectiveness of the device. Sheeting that is torn, peeling, cracked, or splattered with asphalt or concrete will not perform well under the best conditions, but it's particularly bad at night. Routine cleaning and replacement of signs and channelizing devices should be encouraged, if not required outright by the plans. Construction dust alone can diminish brightness by 50%. Worn out or damaged sheeting will reduce it even more. Lighting devices must be maintained too. The manual has established minimum performance standards for warning lights. Type A low-intensity flashing lights and Type C steady burning lights should be maintained as to be capable of being visible from a distance of 3,000 feet on a clear night, providing there are no sight obstructions. Type B high-intensity flashing lights should have a daytime visibility of 1,000 feet without the sun directly on or behind the light. As with other devices, warning lights must be maintained at an acceptable level of safety. The contractor should replace bulbs and batteries on a regular basis and respond immediately to emergency maintenance requests. Some agencies have established minimum levels of maintenance of warning lights. They may require a certain percentage of all lights to be working. When the lights fall below that level of acceptable performance, the contractor is notified of the need for service. But when there is no prescribed level of maintenance, you have to make a judgment based upon what a driver is likely to see and conclude. A question to keep in mind is, do the lights help present a clear pattern that shows the driver where the road goes? When they don't, it's time for the contractor to come in for a service call, and soon. Other lighting devices, such as arrow panels and changeable message signs, have to be kept in good condition, fueled up, level, and working, often around the clock. Burned-out bulbs need to be replaced promptly so that these important devices can provide drivers with a clear, easily understood message. Most arrow panels have automatic devices that dim the lights during hours of darkness. Make sure it works. At night, an undimmed arrow panel is bright enough to blind approaching drivers. Pavement markings, too, need to be kept up. Restriping or replacement of raised pavement markers ought to be done according to plan, on a scheduled or on an as-needed basis. Delineation of concrete or other types of positive barriers require close inspection. Type C lights or other delineation devices need to be serviced before they fail. By now you get the idea. There's no such thing as a maintenance-free traffic control device. Maintenance has to be a key element in all our traffic safety efforts. With all this emphasis on traffic control devices, it's easy to overlook one of the human elements of traffic control, the flagger. When you inspect a flagger operation, here are some things to consider. First, does the flagger have the proper equipment? An approved stop-slow paddle, safety vest, proper clothing. Second, does the flagger use the proper flagging signals and allow enough time for drivers to react? Is the flagging station in the best location? Are the correct advanced warning signs in place? Document any problems with flaggers and bring them to the attention of the contractor. Now, as important as these inspections are during the day, nighttime inspections are where you're likely to find the most serious traffic control failures. You should arrange your schedule to permit periodic nighttime reviews of the work zone. Look at it as if you're seeing it for the first time. Are the devices easily seen, correctly placed, and properly maintained? Do they provide that all-important positive guidance? Nighttime reviews are the best way to get an overall picture of work zone performance. Check the reflectivity of work zone signs. All signs should be bright and legible. In many cases, a sign that looks good in the daytime can be totally ineffective at night. Along with knowing the requirements of the manual, the specs, and the traffic control plan, another important part of your job is thorough and accurate documentation of the work performed. For one thing, your records will ensure proper payment to the contractor or provide reasons for the payment to be adjusted or withheld. But documentation has purposes beyond mere bookkeeping. In the event that your agency is called on to defend itself due to a work zone accident or injury, your records may represent the only way you can reconstruct the conditions of the worksite on a particular date and time. Your daily record should document all traffic control activities and problems that occurred on the project. Include dates, times, weather conditions, and so on. Use photographs, drawings, and diagrams to clarify your reports. As I said earlier on in this program, inspecting traffic control isn't much different from other kinds of inspections. It comes down to knowing the requirements of the contract and plans and seeing that they're carried out on the job. The only way to do that is to make regular inspections of the work zone throughout the day and at night when the real problems show up. Then, of course, you need to document your findings. These three activities, know the requirements, make routine inspections, and document the results, will see you through most inspection duties, including traffic control. As road building professionals and technicians, we are all responsible for work zone safety. It's our job, and people have a right to expect it from us. As the inspector of work zone traffic control, you do your part by keeping the thin orange line of protection intact. For additional information and training materials on work zone traffic control, contact the American Traffic Safety Services Association, ATSSA, at 5440 Jefferson Davis Highway, Fredericksburg, Virginia, 22401, or call us at 703-898-5400.